3 of the presentations are political in nature, and 5 are about mathematics. If the presentations are placed in random order, what is the probability that each presentation on like subjects are placed together? In other words, that you have all the math and then all the political, or vice versa. So I am asking a probability on this one, so we're going to end up figuring out the probability of this happening. In order to find this probability, it looks like the only real probability methods we've found so far is either n of e over n of s or binomial. This definitely does not appear to be binomial. Remember, in binomial you have repeated trials, and whether or not you get a success on the first doesn't impact the success on the second. You're counting the number of successes. None of this really makes sense in the context of this problem. So it's definitely going to be a counting problem on both the top and the bottom part of this fraction. So to figure out what this counting problem is going to be, we're going to figure out the number of ways that we can have all the like subjects placed together. In other words, all the math and then all the political, or all the political and then all the math. So there's essentially 2 different ways I could do this. I could do all the math, then all the political, or vice versa. And for each of those, there's a certain number of ways that I can arrange the individual presentations. So if I'm dealing with the political presentations, there'd be 3 factorial ways that I could order those. I am kind of jumping through this. This is without replacement, and order matters because I'm talking about a number of ways I can arrange these things. So we're definitely talking about a permutation. And the subset of permutations, since we're being exhaustive with permutations, it's actually a factorial. You could think of this as 3 permute 3 if you wanted to, though. So that would be the number of political presentations that are political in nature, or the number of different ways I could arrange those. And then we have the number of ways that I could arrange the mathematics presentations. So we get 2 times 3 factorial times 5 factorial. As far as n of s is concerned, the total number of ways I could arrange all of the presentations, regardless of their content, this would be 8 factorial. There's 8 presentations, and I'm arranging all 8 of them. So this would be 2 times 6 times 5, I believe is 120. Five factorial is 120. And 8 factorial is 40,320. That would be the probability that all the presentations of the like nature, or of the like subjects, are placed together.